Before we start with the part C, the last part of this question, let me recap what was that we did on parts A and B. We started with a sequence UN, that was an arithmetic sequence, and we write it here, the arithmetic sequence, and we built a sequence Vn with terms being 2 to the power of the corresponding term in the U sequence. And we saw that this new sequence is a geometric one, and we proved some things about it. So now, let's see what the question C, part C has for us. Now we start with a geometric sequence, Wn, and we know the first term, P, and the common ratio Q, and P and Q, they have to be both greater than 0. And we build another sequence, Zn, that is for each term we take the logarithm of the corresponding W term. And what we want to find is the sum of the first n terms of this new sequence, so we want to find the nth partial sum, and our answer is going to be in terms of logarithm of, it's going to be of the form logarithm of k, and k is going to be in terms of n, the point up to where we are summing, p, the first term, and q, the common ratio. The question doesn't ask for it specifically, but we need to see what kind of function what kind of sequence Zn is, so we figure out how to sum it. So Zn is the logarithm of the term Wn, and then Wn, we know it's geometric, so it's going to be p times q to the power of n minus 1. So over here, we're going to have the logarithm of p multiplying q to the power of n minus 1. And that's the same as saying the logarithm of p plus the logarithm of q to the power of n minus 1 using properties of logarithms. And using properties of logarithm one more time, I'm going to write the second term as n minus 1 multiplying the logarithm of q. Okay, beautiful. So for each value n, this sequence is given by a number, the logarithm of p, and then we're going to have n minus 1 multiplying logarithm of q. Just notice one thing, that Z1 is actually the logarithm of W1, so it's a logarithm of p, so actually this is the first term, and then we have this is a d, a common difference, because on each step what we are doing is multiplying that common difference by n minus 1 and summing the first term. So in other words, our new sequence is an arithmetic sequence, and well, we just have to find the sum of the first n terms of this sequence, but we have a formula for that, so let's look in the formula booklet. I'll copy it here. So according to the formula on the first version, this is going to be n divided by 2, and then multiply by 2 times the first term, so that's logarithm of p, plus n minus 1 times d, which is the logarithm of q. Okay, this is not yet in the form we want, so we need to rearrange this to get it in the form we want. So now I'm going to use the properties of the logarithm to get this 2 multiplying the first logarithm and this n minus 1 multiplying the second one as exponents inside those logarithms. So it's going to be n over 2 times logarithm of p squared plus logarithm of q to the power of n minus 1. Now we have a sum of logarithms, so I'm going to write that as the logarithm of the product. So logarithm of p squared times q to the power of n minus 1. And one more time, I'll take the factor n over 2 that is multiplying outside the logarithm as an exponent inside. So this is the logarithm of p squared times q to the power of n minus 1. All of this to the power of n over 2. We'll try to simplify this expression, but we already have an answer in the form logarithm of k, where k depends on n, p, and q.